All right, hello once again. This is Jeff Scott of Rankin Technical College, and as part of the Rankin Technical College AWD 1000 Web Development Technologies class, I've been creating a series of video presentations based on the Mozilla Developer Network Learn Web Development series. So far, I've gone through the getting started with the web, structuring the web with HTML, styling the web with CSS, and now I'm on dynamic client-side scripting using JavaScript. So we're taking it from the top. What is JavaScript? As it says in this article, we will look at JavaScript from a high level. So it's the 35,000 foot view. So it's very general, very generic in nature. What is it? What can I do with it? Now it says JavaScript is a scripting or programming language. Now I don't particularly myself like that verbiage because it implies that a scripting language is not a programming language. And there may be scripting languages that are not programmatic in nature, but JavaScript actually is a programming language. To many people, JavaScript is either the best first programming language to learn or the worst. And it's the best because it's very forgiving. And if you forget to do something, JavaScript typically will do it for you behind the scenes. That's the good. It's also the bad in that what can happen then is you can develop bad programming habits in JavaScript where you are allowed to maybe get away with certain things, whereas in other programming languages, you're not allowed to get away with those things. Okay. As it says, it allows you to implement complex features on web pages. So really, more than anything else, it allows you to do interactivity on web pages. All right, you can read all of that stuff. It says it's the third layer of the layer cake of technology. So far, we've gone through HTML, the hypertext markup language, which allowed us to put the content on our web pages. CSS, cascading style sheets, which allowed us to add the aesthetics. And now we have JavaScript. So here's how they describe them. HTML is a markup language, and it is, used to structure and give meaning to web content. CSS is a language of style rules that we use to apply styling to that content. And JavaScript is a scripting language, or really, like I said, basically it really and truly is a programming language, all right, that enables you to dynamically and to do things with the web that basically allow for interactivity. Okay? All right. It says, let's take an example. We can mark up HTML to give it structure and purpose. So we've got a paragraph here that says this. Fine. Then we can add some CSS to that paragraph. When we get done, it looks like this. All right. Finally, we can add some JavaScript. Now, this may be the first time you've seen any JavaScript. So if that's the case, don't let it throw you because we're going to go over what stuff like this in here means. All right. Let's just talk about it. It says const para equals document.query selector p. So this is going to go in and find the paragraphs that are in our document. Well, that paragraph that it's going to find is this one. All right. So it's going to look for paragraph content. Then it's going to add an event listener to it, which says when you click on that paragraph, you should call this routine called update name. Okay? And then when that runs, the first thing it'll do is it'll have this prompt. And when it has this prompt, there'll be like a little message box that'll come up over here that'll say enter a new name. So I come in there and I enter in Jeff. And it should then come in and change this from player 1 Chris to player 1 Jeff. So it says try clicking on this latest version of the text label and see what happens. So there it is. So I'm just going to say Jeff. And you'll see how it changes. All right. Now that's not a gee whiz type of thing, and don't worry about that. And as they mentioned, there's a lot more, meaning there's a lot more that you can do with this. So what can it really do? The core client-side JavaScript language consists of common programmatic features that allow you to do things like store useful values inside of variables. So what's a variable? It's a named memory location, whose value can vary, hence the name. It allows you to do operations on pieces of text known as strings. All right. One thing to notice about in here, this string here and here are inside of double quotes. Strings have to be quoted. You can use either single quotes or double quotes. But if you start it with a single quote, it must end with a single quote. If you start it with a double quote, it must end with a double quote. Now, in most other programming languages, you use double quotes for strings and you use single quotes for one character. JavaScript is different in that way, but most of the time, when I'm given my choice, I use double quotes. With JavaScript, you can run code in response to events. You already saw that, where we clicked the button and it came up and it asked us to enter a name. Okay. What is even more exciting, as it says, is the functionality built on top of client-side JavaScript. APIs provide you with extra abilities, let's just say, to use in your JavaScript code. Now, for whatever reason, they're going into them right here, which is fine. But it says APIs are ready sets of code building blocks that allow you to develop and implement programs that would be otherwise difficult, if not impossible rather, to implement. They do some built-in things for you. The authors here liken APIs to ready-made furniture kits, where it's much easier for you to go to IKEA and grab something and put it together, as opposed to you sitting there getting the wood, sawing down the tree, cutting the panels, screwing them together, etc. Okay, so they mention here that generally APIs fall into two categories. Now they've got third-party APIs and they've got browser APIs. So what's the difference? Browser APIs are built into the browser. I mean, that sounds like a big thing, but it means that you get them for free, for lack of better words, with JavaScript. Third-party APIs are created externally, someplace else, and you bring them into your program. So here are some examples of browser APIs that are built into the web browser. The first is the DOM, or the Document Object Model API. And I've said this before. I don't know if I've said it in this series of lectures or not. But if you can understand how to utilize the DOM, that's probably would make you more valuable as a web developer than probably just about any other skill there is. Because as it says, it allows you to dynamically change things on your screen. All right, so while the program is running, in other words. All right, other browser APIs include the geolocation API to retrieve geographical information. As it says, it's how Google Maps works. The Canvas and WebGL APIs to allow you to create 2D, two-dimensional, and three-dimensional graphics. Audio and video APIs, which will allow you, as it says, to do things like play audio and video right in a web page, grab video from a web camera and display it on someone else's computer. All right, they've got demos in here. I'm not going to go through those. Feel free, of course, to do that yourselves. Many of the above demos won't work in older browsers. When experimenting, it's a good idea to use a modern browser like Firefox, Chrome, Edge, or Opera. I have been using Chrome and will continue to do so. So those were some examples. It's not an exhaustive list, but some examples of browser APIs. As far as third-party APIs, well, Twitter, Google Maps, OpenStreetMap, OpenWeather, Facebook, okay? As it says, these APIs are advanced. You can find out more of these in our client-side Web APIs module, which I believe we'll cover at a later time. And again, it says there's many more available too. What is JavaScript doing on your page? Oh, we're doing just fine time-wise. says here we'll actually start looking at some code, and while doing so, explore what actually happens when you run JavaScript on your page. Let's briefly recap what happens when you load a web page into the browser, which we talked about a long time ago. When you load a web page into the browser, you are running the code inside of what's called an execution environment, so inside of your browser. That code is basically a combination of your HTML, which loads first, your CSS, which loads second, and then your JavaScript, which loads last. As it says, this is kind of like a factory that takes in these raw materials. So these are your inputs, this is your processing, and that'll be your output. All right. A common use of JavaScript is to dynamically modify HTML and CSS to update a user interface. Note that the code in your web documents is generally loaded and executed in the order it appears on the web page. If the JavaScript loads and tries to run before the HTML and CSS that it is affecting are loaded, either errors can occur or nothing might happen. And that's basically the best case. The worst case, you'll get errors, but you won't get the results you think you're going to get. As it says, we'll learn ways around this later on. All right, browser security. Each browser tab has its own bucket for running code. So for instance, I've got my I Love Missouri that we've been working on for a while. Here's the what is JavaScript. Here's a new tab, etc. And I've got other ones running as well. But as it says, each bucket has its own execution environment, meaning that in most cases, the code is run completely separately. So in most cases, the code that I have here, so for instance, in my JavaScript, won't affect the code I've got here, which was back in, still got this up, what we worked on in the last lesson. And it says this is a good security measure. If this were not the case, people could actually go in and try to attempt to open up other tabs in your browser and manipulate what you're doing. There are ways, as mentioned here, that you can code and send data between different websites or different tabs safely. But they're not covered here in this course. This is meant to be to get you up to an introductory to maybe even intermediate level of JavaScript knowledge. All right, the running order. As mentioned, when the browser encounters a block of JavaScript, it generally runs it in order from top to bottom. All right. This means, as it says, you need to be careful in what order you put things. It says, let's go back to the block we had in the first example. Well, you have to create this variable called para before you can add an event listener to it. Now, you'll notice that we've got this line of code before we've got the actual function. So as it says, we're selecting a text paragraph in this line. We're attaching what's called an event listener to it in this line. When you click it, then this routine runs. It says if we swap the order of these first two lines of code, so if we put this line of code first, then this line of code under it, we'd get an error because we'd be trying to use para where para did not exist yet. All right. And it would get a para is undefined error, meaning, like I said, that it does not yet exist. This is a common error, as it says, and everybody runs through it. Everybody makes errors like this once in a while. We all do it. Even experienced programmers do it. All right. Next, it says interpreted versus compiled code. And as the author mentions right here, it says you might have heard the terms interpreted and compiled in the context of programming. In interpreted languages, the code is run from top to bottom and the result of the running code is immediately returned. You don't have to transform the code into a different form before the browser runs it. The code is received in its programmer-friendly text form and processed directly from that. Compiled language, on the other hand, are transformed or compiled into another form before they are run by the computer. The program is executed in a binary format, which is generated from the original program source code. Now, I'm going to give you my take on this. There are other people who might hear what I'm about to say and disagree, or to say that maybe the way I'm putting it isn't the best way, but I like to put it in ways I think that people, especially people without much experience, can understand. So imagine that I'm walking down the street and I am encountered by a person who comes up to me and starts, maybe they introduce themselves to me, but we understand after we do this that they speak only French and I speak only English. So there's really not a good way for us to converse. Well, lo and behold, another person walks down the street, and that other person is a translator. So they know both English and French. So I can say something to the translator in English who can translate it into French and tell the person in French what I just said. They can take what the person answers in French, translate it into English, and tell it to me. All right. Now I'm going to even take this a step further and say something. This is one of those stories I've never told before. All right. My daughter was in college and got her degree, I'd say somewhere around 10 years ago. She got a psychology degree, and while she was in there, she played soccer. And the reason I'm telling you this is one person on her soccer team was literally from France. In fact, she lives there right now. And what I like to do is when it's her birthday, tell her happy birthday on Facebook in French. So I come in here and I type in happy birthday French. And you can see it is bon anniversaire, something like that. Maybe I'm not pronouncing it correctly. So I'll typically put that in and she'll come back and say merci. And she calls me Papa Scott. But you get the idea. That's my translator. All right. Well, what does this have to do with what we're talking about? Well, imagine that every time I say something and the interpreter does not know the French equivalent of what I'm saying in English, they have to say, hold it, stop a minute. And they pull out a English to French dictionary, look it up. Once they've got it, they're like, okay, you can continue now. And then they find something else. And, oh, you got to stop again, type of an idea. That's more or less like an interpreted language. So with a language like JavaScript, if I've got a program with 10 lines in it and the first 2 lines execute and there's an error in the 3rd line, it'll stop execution until I fix that line and then rerun the program. On the other hand, with a compiled language, if I'm sitting there and I'm saying all this stuff and my translator doesn't understand something, they just write down, oh, I got to look this up. Oh, I got to look this up. And when I get all done speaking, then they go and look everything up. So what does this have to do with programming languages? Well, if you've got a language, for example, like let's say C# is a compiled programming language. So it'll run through the whole program, and even if there's multiple errors, it'll just flag and list all those errors. But typically, if there's one that's bad enough, it will stop. But with an interpreted language, it does literally stop right then and there. All right. That's, like I said, that's my take for whatever it is or is not worth. JavaScript is a lightweight interpreted programming language. The web browser receives the JavaScript code in its original form and runs the script from that. Most interpreters actually use something that's called JIT compiling, JIT for just in time. It says the source code gets compiled into a faster format while the script is being used so it can run as quickly as possible. But it's still, again, an interpreted language. All right. All right. We're at almost 20 minutes, so I'm going to stop right here and pick the next thing up in the next part of this lesson.